draw diagram. Through diagram, it'll be very easy to manage. There's a pulley. So here on, we have, there's a reference point. So on one side, we have a person. This is a load, and we have a ladder here. So with the person, let it be at the midpoint here. There's a person, and here is that is what, no, mass of, is there no ladder of mass m minus m? So there's the initial diagram. I'm assuming it. So the person starts climbing up. It's asking now the displacement of center of mass. Look at what is being asked. Then the displacement of center of mass of the system. Man plus counterbalance plus ladder string. Counterbalance is this m. Ladder, capital M minus small m, and mass m. So initially, what is the thing? I think it's in equilibrium, no? So the weight mg will act on this side, m minus m and mg. And initially let the person be at a distance L. Is a person. Okay, no. So as he climbs up, anything will happen. So for him to climb up, what he should do? He should hold that ladder. No? He should press that ladder. You better take, this is similar to rope. So how he can climb up? When he presses hard, there friction will be generated. So tell me in what direction the friction, the tension in the both the strings will increase, no? Because of increasing tension, what should happen to this block? Counterbalance, this called like a block here. So the block should ascend. Then the person will rise up. So ladder, what happened, will descend here. So here the next condition is, let me take this one. So here is what? The block. I've seen very few students who really draw diagram. To be frank, I'm telling. We have most of the students who end up with answers and they're able to think only till there. They're unable to analyze further. Okay, no, I think at least okay, what should be the ladder? Ladder should descend, no? So we have, this is a ladder. So the person climbs up the ladder and he will end up here. So let the displacement of this be y naught. So this should also be y naught. And initial displacement, any symbols you can take help of. Initial displacement is y, and initially the center of mass, the center of the ladder be at a distance y2. Your problem will get over within next step once you're able to write this one. So what is this? I'm taking this as origin. So at what distance the person will be no y2 plus y0 minus L. This will be the position of person. And at what distance the center of the ladder will be? The center of ladder y2 plus y0. Now I'm asking question, what is the net force on the system along y-axis, zero or non-zero? I think that is very important. With that only we have to proceed further. Look at the dot. So this is m minus m. And what about the mass of person? M, small m. Mass of the person is m. Can you hear me?
Yes, sir.
Yes, sir.
Okay, now we'll continue this one. Okay, fine. This is so now what is the net force on system along y-axis? Zero, non-zero. So so earlier the tension T. Let's assume this. Now the person climbs up. As he climbs up, he has to press hard. No, suppose you are climbing up ladder. What you do? You press hard with your toe, no, or with your legs. That particular horizontal, that one. So definitely, slightly tension will increase. T plus delta T. Here the tension will increase. So correspondingly here will increase. So earlier the tension was balancing mg and on this side mg. So as it starts climbing up, the tension will, there'll be increment in tension. So what is the net force acting on system? Will be upward, no? So there's a net force is acting on system in what direction? Upward. So center of mass will shift along y-axis. Any reason for that? As the person climbs up, as the person climbs up, as the person climbs up, there will be an increment in tension in the string. It will climb slowly. So gradually what happened? The center of mass, the block M will move up, the ladder will move down and the person will be climbing up. There'll be increment in tension. So therefore net force along y-axis, net force will be non-zero along y-axis. So what happened to center of mass? Will shift. So therefore center of mass shifts upwards. This is the idea, background. Okay, how to calculate that shift in center of mass? So it's all about now writing equation. No? Nothing else there. Initial position of center of mass will calculate YCMI from with respect to what we should calculate from here. This is the origin. Write down the equation. Now you'll get answer very easily. There's a background is what you have to set up here. So I'll make it. We'll write down the equation. So YCMI is equal to M Y1 plus M minus small m Y2 M into Y2 by M capital M minus small m plus small m. What about YCMF? M Y1 minus Y0 M Y1 minus Y0 m minus small m, position of the ladder, y2 plus y0, person, all divided by so what is delta YCM? The difference of these two. YCM F. When you take difference of these two, solve it, no? What about the first one here only? I think it's quite easy, no? We'll have one equation, then we'll proceed. So what is YCMI? Minus small m, so this will get cancelled out. So y1 plus y2 by 2. Look at the calculation, it's quite easy. Minus m plus m will get cancelled, denominator. Minus my2 plus my2. So my1 plus my2. Okay, this is a YCMI. Anybody in the world, he can solve this problem if he draws diagram. That's what I believe. It doesn't, the science doesn't belong to any person, intellectual, non-intellectual, nothing. Anybody puts effort, you learn science. You know, we have a wrong perception that, so y1 plus y2 minus, this will be small m by 2 capital M. So the difference of this, so finally what we'll get it, small m L by 2m. Why the difference? Because it will shift upward. The position of center of mass will shift upward. So what is delta YCM? Should be equal to ml by 2m. Small m it is, just be careful. If he climbs with a speed, can we calculate velocity of center of mass? mvr by 2m. If the person climbs up with a speed, then you have to differentiate, no? dl by dt, dycm by dt. If a person climbs up the ladder with a speed vr, then what is the velocity of center of mass? This one should be vcm. What is vr? Velocity of person with respect to ladder, not with respect to ground. Relative velocity is relative velocity of person with this. If he climbs up the ladder with a speed vr, then the velocity of center of mass will ascend upward with this much of thing. And there's a very important concept where the ladder idea is what we have brought it. In fact, center of mass shifts. So you do get problems where center of mass will shift, will not shift. You have to be careful. How to check it? Look at the net force on system along y-axis, 0, non-zero. Along x-axis, 0, non-zero. If it doesn't shift, okay, well and good. If it shifts, then take the problem.